Oi.
Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okey, nampaknya ketiga-tiga penceramah kita sudah berada dalam talian. Saya serahkan program ni kepada moderator yang telah dilantik. Terima kasih.
Assalamualaikum. Boleh dengar ke?
Waalaikumsalam, boleh? Boleh dengar?
Waalaikumsalam, boleh dengar, boleh dengar.
Boleh.
Mengumumkan kini bermulanya sesi siaran langsung bagi webinar Industrial Talk EPO522 di laman rasmi Cisco Webex. Saya Muhammad Hakim Bimandia, selaku moderator pada petang ini, ingin mengucapkan selamat datang kepada barisan pensyarah pada hari ini. Terlebih dahulu, bagi memberkati lagi program webinar pada petang ini, kita buka program ini dengan umum kitab Al-Fatihah. Amin, amin ya rabbal alamin. Terima kasih di atas bacaan Al-Fatihah sebentar sahaja tadi. Yang berusaha Encik Zuhairi bin Hashim, pengurus kanan Short Term Scheduling in Market Operation and Assessment Unit Tenaga Nasional Berhad. Yang berusaha Encik Muhammad Izzuddin bin Muhammad Izam. Yang berusaha Cik Khairul Husna binti Burhan. Yang berusaha Profesor Madya Insinyur Teknologis Dr. Hasmaini Muhammad, Ketua Pusat Pengajian Kuasa Fakulti Kejuruteraan Elektrik, Barisan Pensyarah Fakulti Kejuruteraan Elektrik, para pelajar Fakulti Kejuruteraan Elektrik. Warahmatullahi wabarakatuh. Salam sejahtera, salam UiTM di hatiku. Saya ucapkan kepada hadirin dan hadirat sekalian. Saya ingin dari industri yang berusaha Encik Zuhairi bin Hashim, dan tidak lupa juga kepada Encik Muhammad Izzuddin bin Muhammad Izam dan Cik Khairul Husna binti Burhan dari Tenaga Nasional Berhad TNB single buyer kerana sudi menyertai ke program webinar Industry to Class untuk subjek EPO 522 pada petang ini. Terima kasih juga kepada semua pelajar semester 5 bagi subjek EPO 522 yang sudi hadir pada petang ini. Sebelum meneruskan majlis, ingin saya ingatkan terlebih dahulu, sekiranya ada pelajar yang mempunyai sebarang persoalan yang ingin ditanyakan berkaitan ajadah kita pada hari ini, sila ajukan soalan tersebut di ruangan chat yang tertera. Sebelum saya memulakan sesi perbincangan ini juga, diharapkan para pelajar dapat menghubungkaitkan apa yang dipelajari dalam kelas dengan apa yang Sebelum kita teruskan dengan talk Encik Zuhairi, saya terlebih Senior Abdul Talib dan Insinyur Zulkifli untuk mengaktifkan
Gambar saya tak keluar lah. Nak guna komputer baru, satu lagi komputer on ada webinar lain. Sorry, tak apalah, just captured the
Sekejap,
photo.
boleh onkan video. Untuk sesi bergambar. Boleh onkan video semua. Okey, senyum. 1, 2, 3. Okey.
Terima kasih diucapkan di sesi penggambaran sebentar sahaja tadi. Sebelum saya membaca secara ringkas biodata beliau. Beliau merupakan graduan Bachelor of Science Electrical Power Engineering dari Ohio State University, United States of America, USA, dan telah memulakan kariernya di Tenaga Nasional Berhad TNB pada November 2006. Beliau berpengalaman yang sangat luas dalam short term generation planning untuk semenanjung Malaysia, dan kini beliau memegang posisi sebagai pengurus dan short term scheduling in market operation and assessment unit TNB. Tanpa membuang masa lagi, majlis dengan segala hormatnya menjemput Encik Zuhairi untuk meneruskan taklimat beliau. Dengan segala hormatnya dipersilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hopefully everybody can hear my voice clearly.
Okey, clear.
Alright, thank you. Okay, first of all, I would like to thank to the moderator just now for the brief introduction, and also we are very honored to be here and happy at the same time to have this knowledge sharing session with all of you. And also I would like to thank Professor Hasmaini and Encik, actually I missed the name just now. It was not clear. In Senior Muhammad Abdul Talib ke? If I'm not mistaken. Correct me if I'm wrong. Okay. All right. um, okay. Again, as I mentioned just now, we are honored and happy to be here to have this session with all of you, the future generation who will be part of our electricity industry. So I'm hoping that you will take this opportunity to learn as much as possible, or at least get to know the fundamental of the generation planning activities that we do on a daily basis. Okay, I think all of you can see the slides presentation in the WebEx. So so basically, our job scope is to conduct or perform the generation scheduling for day ahead up until 3 month ahead generation planning, and to determine the optimum generation fuel planning, namely gas, coal, hydro, and renewable energy for the system. So this topic will specifically be covered in our sharing session. Another crucial process carried out by my team is to produce a reliable demand forecast prior to the optimization process. Can I continue because I can hear noise at the background? So can I continue?
Okay.
Okay, all right. I just continue. Okay, the as I mentioned earlier, another crucial process carried out by my team is to produce a reliable demand forecast prior to the optimization process. The output of this short-term load forecast is the key in determining the right generation planning to ensure electricity demand is met at the most optimum cost. This also will be covered in this presentation by my respected colleague. All right, before we deep dive into the main topic, allow me to give you some introduction of single buyer, which I'm quite sure many of you here are not familiar with this entity. How do we coexist in TNB and the industry? What is our purpose of existence? It may be one of your future career of choice in the future if you are interested in doing studies, analysis, and negotiation. Also, a little bit of updates on our grid system so that you can relate or have a general idea on the main topic for today. So our focus of today, as mentioned just now, as you can see from the slide, there is the agenda for today. All right, can we go to the next slides, please? All right, this is the overview of single buyer. Who is single buyer? Actually, we are one of the entrusted entities appointed by the government to carry out certain specific roles and functions with the objective to promote efficiency and facilitate competition in the generation sector. Ultimately, our reasons of existence is to portray or show transparency in the industry, since we are planning not only for TNB but the independent power producer, or we call it IPP as well. All right. There are 5 core functions, as you can see from the screen. The number one is to procure electricity in a least cost manner in meeting the demand. The keyword here is least cost. Next is to ensure all our activities are strictly following the stipulated rules and guidelines. Hence, this will promote the transparency. The next item is fuel adequacy. This is very important because the on at all time, no matter what. Therefore, a proper planning and monitoring of fuel supply must be in place. We will talk about more fuel in the next few slides. The next one is to ensure the generation or power plant capacity adequacy and reliability via a proper planning. Then number 5 is to facilitate competition in the generation sector via competitive bidding. So we should move on to the next slide. All right, okay, students. As you can see, this is the general structure to show you our stakeholders, customers, and our we can call it cikgu disiplin lah. So basically, there are two ring fence entities in the middle there. You can see at the pointer. There are two ring fence entities within TNB, which are single buyer and the grid system operator. We are reporting to Suruhanjaya Tenaga as the regulator. Then at the top over there, we have the policy and decision maker at the ministry level, Kementerian Tenaga and Sumber Asli, also known as KETSA. So single buyer is regularly called to discuss and provide some insight to the KETSA and STs so that they have the right information for their consumption. We're also serving the customers which are the generators. You can refer to the left side of the middle box. We have the generators and also NEDA participant. So I believe this NEDA is quite new for you, the term. So actually NEDA stands for New Enhanced Dispatch Arrangement. This is a new initiative introduced by the Suruhanjaya Tenaga to allow for certain category of generators to be part of the generation supply to the grid. Then at the bottom, we have the grid system, which is being managed and operated by our counterpart, GSO, ataupun grid system operator. And then we have oversight panel. You can refer to the right. This is the one yang closely monitor our activities in terms of compliance and also performance. Okay, next we have a short video to share with you. The duration is about 3 minutes, which from this video, it could summarize what single buyer is all about. So please pay attention to the video.
Single buyer is a ring-fenced entity entrusted to manage planning and procurement of electricity in Peninsular Malaysia. Single buyer ensures the nation receives electricity at optimal cost by planning for the system by providing long-term demand and supply outlook, conducting generation scheduling and operate NEDA, providing advisory services to industry stakeholders, negotiating and managing generator contracts for energy procurement, processing generator settlements and manage imbalance cost pass-through activities under the Incentive-Based Regulation or IBR. Single buyer was established in September 2012 as part of the 9+1 Malaysian Electricity Supply Industry MESI Reform Initiative. Before the establishment of single buyer, system planning and energy procurement functions were carried out by two departments in TNB under the Planning Division. They were formerly known as System Planning and Development (SPD) and Energy Procurement Department (EPD). Single buyer is ring-fenced as part of the IBR framework. The ring-fencing arrangement becomes mandatory in the Electricity Supply Amendment Act (ESA) 2015. So, what is ring-fencing? Ring-fencing is separation of accounts, business activities and governance of an entity from the rest of the company. Ring-fencing is required to improve transparency and address the perception of biasness that may cause conflict of interest to any market player. How is single buyer ring-fenced? Isolation of accounts and cost allocation in electricity tariff. Single buyer's operational expenses and payment to generators are kept separate as per IBR implementation. Physical separation. Relocation of single buyer's office outside TNB premises. Single buyer's office is now located at Bangsa South. Limits on sharing information. Ensure non-disclosure of information that may cause conflict of interests and provide competitive advantage to any party. Arm's length operation. Interactions with other departments in TNB are now governed by Service Level Agreements (SLA). Establishment of corporate identity, such as logo, letterhead, email, and website. The ring-fenced operation of single buyer is governed by Guidelines for Single Buyer Market and Guidelines for NEDA issued by Suruhanjaya Tenaga. In dealing with the industry players and stakeholders, single buyer's operation is also governed by ring-fencing guidelines, Single Buyer Operations Manual, Code of Conduct, Standard Operating Procedure, and Conflict of Interest Agreement. Single Buyer has started the transformation journey via ring fencing to support the evolution of MESI. We are committed to promote efficiency, transparency, and competition in the power sector. MESI's sustainability is our priority. Single Buyer is proud to stand behind the nation's vision.
All right. Thank you. That was a short video. Hopefully, you can by now you can have an idea what a single buy is all about. All right. Thank you for your attention. So now, just a quick information on the legal requirement. Can we move on to the next slide? So this information actually is we would like to emphasize the basis of our planning activities. It is not something that we do for fun. It is actually based on some regulatory requirements. So we have the Malaysian Grid Code, guidelines for single buyer market in Peninsular Malaysia, and also some other legal documents such as power purchase agreement, gas framework agreement, and etc. These documents actually govern our planning activities to ensure it is reliable, efficient, and transparent. So, can we go to the next slide, please? All right, as you can see, this is the Grid Code. In this Grid Code, there are several clauses that refer to the list cost, which shows you the requirement of list cost and the general concept of list cost scheduling and dispatch. So I'm not going to read all the clauses over there. Just to let you know that we have the governing documents that shows you the responsibility of single buyer in doing the day-to-day planning. The next document is the single buyer guidelines. Similarly, there are several clauses that refer to the list cost, which expresses the requirement on the list cost and the details of its implementation. Okay, enough with the boring stuff. Now let's look at the system updates of Peninsular Malaysia. So for this particular update, I will pass it to this presentation to my respected colleague, Encik Izzuddin.
Okay, thank you, Encik Zahiri. Okay, Assalamualaikum and a very good afternoon to all. So, semua boleh dengar ke?
Boleh.
Alright, okay, I am Izzuddin, and today I will talk to you guys about the system updates of Peninsular Malaysia. So, feel free to ask me or to interrupt me during this discussion, okay? Alright, so in Peninsular Malaysia power generation, the coal capacity dominates the whole generation capacity mix in Peninsular Malaysia, followed by gas, hydro, and solar. So before that, I'm assuming that these terms in these particular slides are familiar with you guys, the future electrical engineers, right? But feel free to ask if you are unclear with these terms. So, okay, look at the left-hand side of the slide. The highest demand ever recorded is 18,808 megawatt, which is on the 10th of March 2020 at 4:30 p.m. Quite a few days before the first phase of MCO in Malaysia. And the highest energy also recorded on the same day as well, which is at 394,000 megawatt hour. If you want to study how big is the energy's magnitude, you can take a look at your home's electric bill, take a look at the usage, and you can calculate maybe satu kampung use how much of energy. I mean, if you guys are engineering student, you guys must be love maths, right? Okay, anyway, the total installed capacity of the system updates as of 8th of September 2020 is 24,868 megawatt. And what is installed capacity? So installed capacity is the max capacity that is spelled out in the agreements. So we see that the coal-fired power plant contribute to 48%, which is almost half of the total capacity. So yes, you can see Malaysia depends a lot, hugely on coal for electricity. And then we have gas contribute to 39% of the mix, followed by hydroelectric at 10%, and large-scale solar at 2%. So why the solar is quite small? Actually, solar is quite new in our system. It's the recent initiative by the government to promote renewable energy to cut down the CO2 emission. So as we look at the peninsular map, the dots represents the power plants based on their respective colors of fuels. So we can see that the northern region has the highest capacity, which is at 40%. And then the southern by 33%, followed by central, which is Selangor and KL at 19%, and the east coast has the least at 8%. So we can observe that based on this map, most of the plants are located near to the shore or to the sea. Anyone knows why? Okay, well, first it is because they need the seawater as a cooling agent in their machinery system. So it's closer to the sea to take the seawater. And then for the coal power plants, they acquire the coal through ships. We import coals from various countries like Australia, South Africa, and even Indonesia have the hence the plants near to observe at the bottom of the map to the south. We have interconnection connected to Singapore. It is connected by HVAC, so it is just used as a frequency regulations. We can't purchase electricity from Singapore. Whereas up north, we have interconnection connected to Thailand and Laos via HVDC and HVAC. So we can actually purchase electricity from them. And yeah, we are not physically connected to Laos, but if you purchase from Laos, Thailand will be the orang tengah to help to send the electricity to interconnection at Gurun, Malaysia. So to the next slide. So we will go into a bit details of the power plants in Malaysia. First off, we'll with the northern region that consists of Perlis, Kedah, Penang, and Perak. So northern region has lots of hydroelectric power plants. This is because they have a huge lake and long rivers. So Sungai Perak alone consists of few plants. The plants are cascading, which mean by bertangga. They have at the top the Temenggo, which has the largest lake. And when Temenggo discharge the water to generate electric, the water goes on to fill the lake at Bersias Dam. And this continue to Kenering Dam, and then the bottom one is Cendero. And when Cendero discharge, the water will be used by the people downstream. So it's like Temenggo up top, and then Bersia, and then Kenering, and then Cendero. Okay, then we have the coal power plants, the SJ Manjung, that consists of 3 units of 700 megawatt and 2 units of 1000 megawatt, that totals up to 4080 megawatt. SJ Manjung is one of the early coal plants in Malaysia, around 2005, I think. It started to operate around 2005. If you guys wonder what is SJ means, it is Stesen Jana Kuasa. Okay, for gas plants, we have Perlis Power at Perlis. And then we have SJ Gelugo on the Penang Island. SJ Segari that have 2 units of 650 megawatt, total up to 1,500 megawatt. And SJGB3, they are located in Lumut. There is only around 20 minutes to the coal SJ Manjung. And for the solar plants, we have a few in Kedah, which is LSS Bukit Selambau, Gurun LS, and Kuala Ketil. Whereas in Perak, we have Bido Solar, Kerian, and also Sungai Siput. As you can see, the megawatt of the solar is between 30 megawatt to 50 megawatt. For your information, the requirement to be a large-scale solar plant in Malaysia is to have a minimum of 30 megawatt. And as for now, 50 megawatt is the largest solar plant that we have. Okay, we move to the next slide. So for the eastern region, you can see that East Coast has less than 10% of the capacity distribution. If you wonder why, it is because of the much lower load demand usage at the east. And if we were to build there, long transmission line is needed that will incur more energy losses and will cost a lot more money to build them. Okay, so at the east, we have one LSS in Merchang, Terengganu, 50 megawatt. And we have 2 LSS in Pahang, at Gebeng and Gambang. If you guys actually selalu-lalu the LPT, you can actually see the Gambang Solar, tepi highway, maybe some part of the highway. And yeah, the large-scale solar is really, really huge. I mean, really wide. They take a lot of land. And for the gas hydro, and for the hydro, we have Hulu Terengganu and Kenyir in Terengganu. There are 4 units of 100 megawatt in Kenyir that total up to 400 megawatt. Just a little bit of sharing regarding Kenyir. If you ever read or receive on social media about empangan Kenyir TMB lepaskan air sebabkan banjir dekat Terengganu, please take note that that is all false. Banjir at Terengganu happened because of 2 reasons. First one is the high tide at the Pantai Timur. High tide, which means the air pasang. And then the high inflow of the river in rivers around Terengganu at the downstream. So generally do not spread the unsure news of the Kenyir empangan, okay? And we have one hydroelectric plant at Pergau in Kelantan that totals up to 600 megawatt. Okay, as for the gas plants, we have YTL Parker, 2 units that total up to 585 megawatt. Okay, so we move on to the next region, the central region. We have 3 gas plants, SG Connaught, Putrajaya, and Kuala Langat. Before that, are you guys familiar with the types of gas power plants? For example, the SG Connaught is a single shaft gas plant. The latest technology is of gas available in Malaysia. Whereas the SG Putrajaya is an OCGT power plant, which means by the open cycle gas turbine. And the Kuala Langat is a multi-shaft tech machine, or also a combined cycle gas turbine, CCGT. Maybe you can study deeper on this later. or you can ask your friends in mechanical engineering about the open cycle and combined cycle. So as for the solar at the central, for now we have only one at Sepang. This one in Sepang is fully owned by TNB. Maybe you guys can request for a visit at the solar plant, but only after COVID is done, or no more online classes. Then we have SJ Kapar running on coal, one of the earliest coal plant to operate in 2004. This plant is quite unique. They also run on gas or distillate in this facility, given we have problem on the coal shortages. Okay, next slide. And then for the southern region, which consists of Melaka, Negeri Sembilan, and Johor, we have 4 gas plants. We have SJ Panglima, CCGT, multi-shaft, that located at Melaka. And then we have SJ Tuanku Jaafar 1 and 2, located in Port Dickson. Also multi-shaft CCGT. And then we have SJ Pasir Gudang at Pasir Gudang, obviously. And we have Pengerang, a plant owned by Petronas that it is a cogen technology plant. And as for the coal power plants, we have SJ Tanjung Bin, consists of 3 units of 700 megawatt and 1 unit of 1000 megawatt, located at Tanjung Piai, the furthest land of East Johor. Then we have SJ Jima, 2 units of 700 megawatt combined to 1400 megawatt, located in Negeri Sembilan. And then SJ Jimah East, actually the latest coal power plant joining our system last year. So this plant is also owned by TNB and actually just next to the SJ Jimah. And as for the solar in southern, we have Chembong large solar in Seremban and Jasin in Melaka, both rated at 50 megawatt. Okay, we move to the next slide. Okay, on this slide, we are going to talk about some details on the solar plants. So this graph shows the typical profile of energy generated by solar. The maximum energy ever recorded was on 29th February 2020. The solar contributed about 2.27% to the system demand on 600 hours, around 4 p.m. like that. And the highest megawatt produced by solar is around 12:30 p.m. to 1:30 p.m., generally like that, where the weather is paling terik. And as we look at the right-hand side of the slide, we can see that Kedah has the highest percentage of solar capacity distribution, followed by the other states. They are pretty much equal. Okay, I think that's all for now. Me. I will pass this presentation to my colleague on short-term load forecasting.
But before that, do we have any question from the students? I believe silence means no.
Hello.
Yeah.
Saya Alif Daniel.
Ya, Encik Alif.
Jelas tak suara?
Jelas, boleh.
Okay. Saya nak tanya pasal yang Malaysia pernah blackout dulu. Yang lama. Seminggu ke 2 minggu?
Itu dah lama dah tu, tahun 90-an kan.
Ya, yang tu. Boleh tak cerita in detail kenapa dia jadi macam tu?
Sorry, saya tak ada that information lah, sebab apa tu, benda tu jadi pun sebelum saya masuk kerja lagi lah. Saya masuk 2006. So basically saya boleh bagi tahu in general sahajalah kenapa berlakunya blackout pada masa tu. Maybe during that time kita punya grid system is not that strong enough as compared to now, and then kita punya generation pun is very limited. Okay, maybe due to that, yalah, maybe because of that, the grid system is not mature enough, and then to cater for the demand, and as well as the supply is not that reliable at that particular time. But if you need to know more about this issue, actually you can I can find out for you. You can give me your contact, and I will get somebody to explain to you the details why such blackout happened in 1994, if I'm not mistaken.
19 early lah.
Yeah, early 90s lah. After that dah tak ada lah this the huge ataupun we call it national blackout, dah tak ada lah. Maybe ada very pockets of blackout lah, not national blackout. Sebab lepas tu kita dah more prepared lah in terms of technology, in terms of knowledge on how to manage the grid system very well lah. Kita learn from other countries, other utilities, and on how to manage the blackout situation. So I'm sorry because I cannot give you the details or the answer that you need for these particular questions. But if you need more details, as mentioned just now, you can give me your email so that we can find out what is the answer, or we can tell you, we can give you the PIC, the person in charge for this information. All right, I can see there is a question from the chat box. Future is solar power plant will be one of the dominant plant in our country. Okay, when we talk about the future, actually solar plant is quite new in our system. Unlike the Western at the Western country, this RE is very advanced and very mature as compared to Malaysia. So at the Western countries, the cost of having this solar power plant, I think is getting cheaper as compared to Malaysia. And then at the moment, kita punya the dominant mix is still coal. Basically, it is due to the cost lah. Sebab among the fuel sources, gas, coal, and the rest though, for the time being, coal is the most is the cheapest lah. And then for solar power plant, bear in mind that even though solar is green, it requires a wide area of land. So we have to consider in terms of land consumption lah. Memang the intention is to cut down the CO2 emission, but we have also to consider to balance lah. We have to balance what is the best position for our country, whether to have all the trees cut down just to make way for solar. So to answer your question, not in the near future lah. In the near future, I think until until 2027, coal will still be the dominant plant in Peninsular Malaysia. And after that, we foresee that slowly this coal plant will gradually reduce, and it will be replaced by gas and maybe solar. For the time being, you can see solar is only 2%, and actually it is growing. We have another 2 phases of solar coming in, both in grid and also in distribution connected. Can we use wind generation power plant in Malaysia? Okay, when we talk about wind, actually we don't have the wind lah dekat Malaysia ni. It's not like country lain yang ada wind wind potential. So kalau wind is not suitable generation in Peninsular Malaysia at the moment because we don't have the wind potential. Kalau ada pun is just for academic research lah, just to understand how the wind generation punya ni lah operation. Alright, kalau tak silap saya yang ada pun dekat pulau perhentian, if I'm not mistaken lah, tu pun ada satu. It's not properly managed sebab I think it's meant for research only. Alright, regarding the LSS, how much is the efficiency currently used in PV system in Malaysia? So kalau kita nak tengok dari segi jelah, dia punya capacity, the biggest capacity for each plant at the moment is 50 megawatts. So dia punya capacity factor is about 20% lah, 20%, which dia tak boleh nak reach 100% lah sebab the nature of the sun, it is a very limited time lah, only during the daytime. Berapa kilowatt power yang connected to Singapore and also Thailand? Okay, as mentioned just now by my colleague Izzuddin. Okay, with Singapore we have 2 submarine cable connection via HVAC 2 by 550 megawatts MVA. So there is the connection with Singapore, and with Thailand we have 376 megawatt. So the 300 megawatt is via HVDC, the DC link, and we have another link with IGAT via HVAC 76 megawatt. So normally yang heavily used with HVDC Thailand, with Thailand is HVDC lah. This is yang everyday kita guna this HVDC link to import and export energy from both countries. What happen if one power plant cannot supply enough energy into certain district? Okay, just a simple simple explanation for that, because we have boleh nampak from this chart itself, kita ada banyak more than 100 units of power plants. So kalau ada satu plant yang tak ada, then it will be replaced by other plants and it will be transmitted into the grid network sampai dekat that certain district area yang affected tu lah. We still have a replacement, don't worry. We have enough reserve margin at the moment. Previously my lecturer told our class that Bakun power plant can generate enough power for entire country. There is a way to connect the power supply between Borneo and Peninsular Malaysia. Okay, actually that was the initial plan lah. To import energy from Sarawak lah, because they have this huge hydro potential in Sarawak. So basically we have done a lot of studies, a lot of feasibility studies to know whether this the line yang kita nak nak supply from from Sarawak to Peninsula Malaysia tu sebab dia kena go through go through submarine cable. It's kalau jadi that project is going to be the longest submarine cable in the world or in Asia Pacific region. So back to yang tadi tu, is there a way to connect the power supply between Borneo and Peninsula Malaysia? Actually, technically yes, but the blocker or the hindrance is actually ini macam back to the political punya decision lah. So when it comes to politik, kita tak boleh nak buat apa-apa. It's up to the government lah. They have to sort this out between them. So if we get the green light from the government to do this connection, I think it can be done. Nothing is possible now. So for the time being, memang tak ada ni lah. Belum ada lagi mandate untuk connect these two Borneo and Peninsula Malaysia. Kalau dapat memang bagus lah. Sebab hydro is considered as green juga, green energy. We are using water to generate electricity. Okay. Which energy source receive the most investment in our country and why? Itulah, as I mentioned just now, kita boleh tengoklah dekat what is the biggest chunk of the generation mix at the moment, which is coal plant. So basically, because of the efficiency, the technology is becoming more advanced. Dia dah boleh improve dia punya efficiency. Dulu sekarang ni kita dah ada ultra supercritical. Dulu kita just the technology was not that mature. Sekarang kita dah ada more efficient plants lah for coal-fired power plant. That is why the mix from coal is high, and also the source lah. I mean, bukan the source, the fuel. The fuel itself is cheap as compared to gas at the moment. Hybrid, wah ni dah apa? Hybrid vehicle, kita EV lah, electric vehicle. So we in TNB we have a department who look into this. The department is called Energy Services, if I'm not mistaken. They are looking into this hybrid vehicle. Okay, as I mentioned just now, kita ada a dedicated department lah in TNB who look into this EV, electric vehicle. And even that team, dia pun ada belilah this EV car for their research purposes. And also dia pun dah ada few charging station. Kalau boleh perasan lah dekat RNR along the highway tu ada tempat-tempat yang kita boleh charge lah. For those yang pakai this electric vehicles. Tesla maybe in the future lah, Tesla not for now lah. Because sekarang ni kita belum ada lagi maybe the framework belum ada lagi, but it is coming. So that is why now we have to be prepared lah. If the technology is here, then we have to be ready in terms of charging station, in terms of payment, macam mana electricity charging semua tu. And how process scheduling for hydro? Okay, yang ini soalan ni from Khairul. Yang ini kita boleh address masa slide lepas ni. Kita ada specific topic least cost generation scheduling. So kita ke Ivy dulu this question. How much is the cost to produce energy per day? actually this information can be it is available in single buyer website. You can go to our website to see what is the cost for every half an hour. How much is the generation cost for Peninsular Malaysia? The information is there. Why big countries using nuclear energy to generate electricity? What are the pros and cons using nuclear? Okay, nuclear pun is a famous option for in power industry. Cuma at the moment we don't have the policy yet lah. Kita punya national kita punya policy still 5-year policy, belum ada nuclear lagi lah. Sebab the difficulty in getting nuclear plant in Malaysia, not only in Malaysia lah, in anywhere in the world, basically to get public acceptance lah. Tu yang paling susah sekali. Sebab nak convince everybody, especially the rakyat lah, whether they can accept nuclear energy, because kalau nak ikutkan memang it is the best option untuk generate electricity. Cuma kita itulah kebanyakan macam orang ada this human can make mistake kan, kita bukan robot, so the chances untuk jadi macam dekat Japan tu, Fukushima kan ada insiden nuklear yang meletup tu. So even dekat Japan pun boleh jadi macam tu. Yang kita tahu dia orang memang very disciplined. Dia punya teknologi is very superb. Disiplin dia orang memang tip top. So kalau nak, yalah, what if benda tu ada dekat Malaysia lah? Can we behave the same like what Japanese has done before? Which I don't think we can do that easily lah. It will take some time. So for the time being, there is no policy for nuclear energy. Alright, and then saya dapat tahu ada certain UiTM develop solar photovoltaic plant sendiri. Okay, itulah kalau regarding this question, actually I would like to know lah the location which UiTM yang itulah, sebab UiTM ada banyak cawangan kan. So kalau nak ikutkan apa yang saya tahu lah, memang ada satu solar plant, we call it UiTM lah, UiTM solar. Dia dekat Gambang lah, Gambang large solar. Cuma itulah saya pun tak sure whether that solar plant tu is owned by UiTM or not lah, but the name itself is UiTM solar lah. So kalau yang Gambang large solar ni, it is a grid connected. So kalau grid connected ni dia memang untuk supply to the grid lah. Maknanya untuk awam lah, untuk semua orang. Not for the local punya consumption lah. Kalau kita cakap yang below 30 megawatts, large solar ni dia connected to the distribution lah. Kalau distribution ni dia mainly untuk local punya consumption lah. Unlike yang grid connected is meant for the grid lah. Okay, what happen if Malaysia guna energy? Saya rasa saya dah cover yang tadi tu. Can we, yalah, kita tengok Japan sendirilah. Right, what if one power plant fails? Is there any delay between transition in the meantime? Okay, actually benda ni pun will be covered, but I can answer this very quickly lah. So kita punya sistem ni ada frekuensi lah yang kita kena maintain at 50 Hz. So katakan kalau ada power plant fails, so this will disrupt kita punya frekuensi lah. So kita punya sistem pun ada certain tolerance yang kita boleh cater. So that is why kita punya sistem ada protection system lah, to avoid any disruption to the system frequency and benda-benda yang boleh lead to national blackout lah. So system kita is very well equipped with the protection. So for example, kalau ada satu plant, kita ambil lah the largest plant so far kita ada apa? Kita ada 1000 megawatts of coal plant. So basically normally kalau this plant trip 1000 megawatt, kita punya demand is around 17 to 18,000 megawatt. So it will disrupt jugalah kita punya system frequency. So in order to arrest the system frequency from go down, bila system frequency ni go down at certain threshold, kita punya system boleh collapse. So untuk arrest this frequency, kita ada beberapa response lah yang boleh arrest the frequency from further dropping. Kita ada hydro. As you know, hydro is the fastest, dia ada the fastest response lah. Kira macam hydro ni kita punya Usain Bolt Malaysia. So kalau kita nak fast response, kita just petik jari hydro, dia pump dia punya air into dia punya machine. So kita boleh dapat the response quickly from hydro. And then kita ada juga response from the interconnection. Kan saya cakap tadi kita ada interconnection dengan Singapore and also dengan IGAT. So kalau dengan IGAT ni pun very fast, few seconds, memang sekejap lah dia boleh bagi kita supply lebih kurang 300 megawatt lah. And then kita ada interconnection dengan Singapore, yang ini pun lagi cepat lah. Dia macam instantaneous lah sebab dia macam a natural punya response sebab dia punya connection itu via HVAC. It's very fast. And then yang lain-lain lah, kita ada plan yang on standby. Plan yang tak jalan tu we call it standby. So at any time kita boleh panggil dia masuk. Cuma untuk plan yang standby ni dia ada dia punya time delay sikit lah. Kalau kita nak panggil tu maybe dia makan masa untuk start up. So sementara nak tunggu this standby plan ni masuk, kita gunakan sources yang tadi tu. Kita ada interconnection, kita ada hydro, and then maybe kita ada saya terlupa. Kita dalam sistem kita ada spinning reserve. Spinning reserve ni memang kita dah allocate ada certain percentage daripada kita punya demand. Dia lebih kurang 1200 megawatt lah. Benda ni memang at all time memang kena ada. So in case ada plan yang trip, so this 1000 megawatt ni will be used first. On top of yang tadi itulah, kita ada interconnection, hydro semua tu. Alright. Ini apa ni? Minister House consider priority. Okay, in terms of priority, mana satu yang nak dapat supply tu, I don't have the answer sebab itu ada satu lagi department in TNB yang deal with the customer lah. Kita on our side kita tengok dekat macro level, macam mana kita nak serve the demand for tomorrow. Kita arrange lah, kita manage the supply, kita forecast the demand based on the supply and demand tu. Kita tengok berapa banyak yang kita boleh kita boleh optimize the resources to meet the demand. Alright, if I'm not mistaken, UTM Solar is under UTM Holdings, UTM Energy and its subsidiaries. Okay, so I believe the Gambang tu is belong to UITM lah, based on this information. Alright, can we proceed? Or ada lagi soalan yang lain-lain? Apa tu? Shutdown maintenance cost will be included in every billing based on my area, since there is almost 7 times shutdown in a week, which also cause damage on our equipment. Thank you. Okay. Dengan power plant. Every power plant kita ada this PPA lah, Power Purchase Agreement. So dalam bila dia buat this Power Purchase Agreement, dia dah embedded all the cost associated for the machine lah. Even shutdown, even maintenance, semua dah factored in into the agreement. So basically shutting down semua ni memang dah catered in the agreement lah. It is allowed to do the shutdown. Tapi kalau dia exceed more than certain numbers of startup, this plant will be will have to pay a certain amount of money lah, which is quite significant for them. So they have to be careful lah on the startup and shutdown of the machine. So kalau yang tadi tu cost damage to your machine tu, I think this is very localized punya issue kot. Very localized punya issue. Maybe this one is better handled by the one yang face the consumer lah. As I mentioned just now, kita in single buyer, we are looking at the macro level, not kita tak sampai ke customer lah. Nak tengok equipment semua tu, there is another department or another unit yang handle that that issue. Okay, any burning question from all of you? Hopefully the question is still relevant in our topic. Okay, or else we can continue. The next presentation is on short-term load forecasting. This will be presented by my respected colleague, Cik Khairul Husna. So, silakan. Tak boleh dengar lah Husna. How about the rest? Can you hear Husna's voice?
No.
No. Tak dengar?
Keluar masuk balik.
Itulah dia keluar masuk balik tu.
Hello.
Hello.
Can you guys hear me?
Yes.
Okay, I think it's better for me not to start my video. Perhaps it's disturbing the connection. Okay, let me begin with the short-term load forecasting. I'm sure everyone wants to know more about generation scheduling, but before we dive deeper into that topic, it is important for you to know about the main inputs of generation scheduling, which is the electricity demand. So what we do in short-term load forecasting, we forecast or estimate the electricity demand that will be used by the whole Peninsula Malaysia, for example, for tomorrow. Okay, as part of the normal process, we'll begin with the input collections. So we have quite a few of inputs. We need a good amount of inputs and a good quality of inputs in order for us to give out a reliable and accurate output. So the first one is historical system demand. This is actually the actual electricity demand used by the whole Peninsula Malaysia. We get this, we extract this data from GSO, Grid System Operator. We also need historical and forecasted weather data. We procure this data from Met Malaysia themselves. They will give us temperature and rainfall for today and tomorrow. We also need another one is historical bulk load data, i.e. steel mill. Why we need this data is because steel mill actually is one of the industry that use a lot of electricity, between 200 to 300 megawatt. So the last point there, if you can see is a bit blurred, is historical and forecasted RE contribution at distribution network. That last point, if you remember Encik Izzuddin explained just now, is about LSS. That one is connected at transmission, but this one is connected at distribution level. So these are the ones that are going to affect our electricity demand. Why is it the point there is not the same color as others is because we are currently in analyzing stage. We are still in the process of collecting data and also analyzing them. So soon we'll incorporate them in as part of our input as well. All right, upon collecting all of these inputs, we'll use these inputs in our simulation. We will use Matrix ND software provided by Itron company. Itron is a company that providing forecasting tool for us. So in this software, we'll have two methods, regression and artificial neural network, ANN. ANN is basically one of the features embedded in the software. So we utilize them and we make sure to have a back and forth discussion with Matrix, with Itron to ensure that our software is at its top performance. Okay, once we're done with simulation, they will give us an output, they will give us a result. This is where the human intervention is needed. We need to do a sanity check on the load profile, whether or not the load profile is following the pattern that it should follow. For example, if tomorrow we have a public holiday, so the load profile should follow a public holiday load profile. Okay, I'll spend a little bit more on load profile later. And it's important for us to do the sanity check to see if there is any abnormalities. And if there is any, we need to go back to the input collection. Basically, it is an iterative process and check whether we have any error in our input data and start from the beginning. All right, when we've done with the assessment and the output that we'll give is half-hourly day-ahead load forecast, which we publish in our Single Bio website. So if you can click the Single Bio website, just to show you guys how our website looks like. I'm sure not many of you have encountered this, or maybe not all of you have actually seen our website. We publish this every day. And not only we publish our day ahead, given that we are short-term load forecasting, given the name, meaning that our horizon is short-term. So we give out a day ahead, a week ahead, and also a week ahead for 7 days to 14 days. Month ahead is for the next 30 days. And the longest one is year ahead for the next 1 year. Okay, this is our website. So if you scroll down, yep, this is our website. If you scroll down, you can see our load profile that I've mentioned a few times. The purple line is the actual demand we extracted from GSO, the grid system operator. So the yellow line is what we published today, the forecast demand for today. Okay. You can look, if you want to find the map Izzuddin presented just now, the one with generators with power plants, you can also find it in our website. We always keep it updated. Okay, Akmal, if you can go back to the slide. These slides just want to show you guys screenshots of our data. Yep. Top left is our historical system demand, our actual demand from GSO. Also, the bottom one is also from GSO, the steel mill. And the top right is an example of our forecast weather data from MET. We receive this data from through email. They will provide us hourly temperature and also hourly rainfall for today and tomorrow. So the purple table there underneath that picture is the actual data, actual weather data, also from MET, also through email. You might wonder why we have calendar there. It's because it is important for us to know what kind of day, what type of day tomorrow is, whether it weekdays or weekends or public holiday, because each type of day they have different load profile. Okay, I think I forgot to mention about how important it is the weather towards our system demand. So to give us a bit more insight how the weather for today is, usually we will use Rain Alarm. Rain Alarm is one of the websites that actually shows the rainfall, the live rainfall in our country. Okay. So this one, if you can see, we have few spots on the west region of Peninsular Malaysia. That spots represent rainfall, current rainfall, and the color represent the intensity of rainfall at that time. So ranging from blue to purple, which means from light rainfall to heavy rainfall. Okay, another website that helps us is windy.com. Okay, windy.com, they have a lot of features on this website, radar, rain, thunder, but we mainly use this website for wind direction and wind speed. So this one is to help us gauge the clouds movement, how the wind direction and wind speed will affect our clouds movement. And you can also use the rain alarm just now for your own purpose. Maybe if you want to go somewhere, you can actually check in this website to see if it's currently raining or not at that place. Okay. Can you go back to the slide? All right. Next is our load profile. I think I've mentioned quite a few times load profile, and you have actually seen one in our website. So this is where the interesting part comes in. Every rise and dip in these profiles, actually, they have their own stories. So let's begin with the blue line. Right, starting from 12:30 to 5:30 a.m., actually the demand gradually slows down because this is when most of us went to sleep and we don't use much electricity, and most of the commercial activities comes to a halt. But interestingly, if you look at the black line, you can see in the circle, black line representing the Ramadan weekday. You can see a bump around 4 to 4:30 a.m. Why is this? Is because we have our sahur, so we need to use our kettle, we need to use our rice cooker. Okay, so you can also see another spike in between 6 to 6:30 a.m. when the majority of us wakes up and prepare breakfast and gets ready for work. And it tapers back down, the demand tapers back down as we begin to commute from our home to our office, to our school, to our university. And you can see that the profile suddenly shoots up significantly. Why? Because this is the time business starts to operate and we can have our maximum morning peak around 11 to 11:30 a.m. And as soon as we begin our lunch break, the demand gradually goes down again and starts to ramp up again. And we can have our maximum demand for the day between 2:30 to 4:30 p.m. This is the time when we go back to the office and also the time when we can reach our maximum temperature between 33 to 35 degrees. And as we begin to commute back to home, the demand gradually decreases and the business also slows down. And upon sunrise, upon sunset, when people return from work, lights are switched on and dinner preparations are made. And we will have our night peak in between 8 to 8:30. This is the time when we have our dinner, we watch television, and we perform family and leisure activities. If you look at the black line again, the Ramadan weekday, we will have our night peak a bit later because we have our iftar and also we have to perform tarawih. And as we goes back to sleep, the demand gradually drops. Okay, it is interesting to see how reflective it is our behavior in the demand profile. I'm not sure if you guys know about the Earth Hour event. The Earth Hour event is basically a worldwide event where everyone needs to switch off their lights for 1 hour in between 8:30 p.m. to 9:30 p.m. So during that time, you can see a sudden drop in demand. And exactly after 1 hour, the demand will increase and goes back to normal. I think one of the other major event is World Cup. So for example, World Cup 2018, where the match actually begins around 4 a.m. So that time, people start to wake up and switch on the light and television. So you can see a bump in the morning. And if I'm not mistaken, in 2014, World Cup 2014, the World Cup was in Ramadan. So we have to wake up earlier for both the match to watch the match and also for our sahur. Okay. So next slide, please. Okay, this is the typical daily load profile. So I've explained earlier about the blue line, the weekdays load profile. So we have our maximum for the day in between 2:30 to 4:30 p.m. But then the red line and the green line, which represents the Saturday and Sunday, they have night peak instead of evening peak in the weekdays. So why do you think we have night peak? Do you guys have any idea? All right, let me just answer it for you. It's because most of the offices close down in the weekends. And also we have a lot more commercial activities at night. So for example, if we don't have COVID, so pre-COVID, we will spend most of our time in the mall. We will watch movies during the weekends at night. So that is why, one of the reasons why we have night peak during the weekend. Okay, next slide. Okay, I mentioned about pre-COVID. How about during COVID? how about during the government implemented MCO to our country? If you look at the black line is actually the weekdays profile, the normal weekdays profile. It is in fact the maximum that we have ever recorded on 10th March 2020 for 18,808 megawatt for 4:30 p.m. So that happened on 10th March, and a week later, the government imposed MCO to us. The red line, if you can refer to the red line, you can see how much significantly the electricity demand drops from the black to the red line. This is when we have our night peak, even during weekdays. And this is the time where the government implemented MCO, where we actually have a total lockdown. None of the business and none of the factories can operate during this time, during the early stage of MCO. Okay, so as the government begins to implement CMCO for PKPB, you can actually see the demand starts to rise up again from the red line to the yellow line, and we begins to have our normal weekdays profile with evening pay. Okay, think that's all from me regarding our demand. I'll pass you guys to a much more interesting topic that Encik Izzudin for least cost generation scheduling.
All right. Thank you, Cik Khairul Husna. Okay. If you guys have any questions regarding the demand system. Or else I will continue with the least cost generation scheduling, and you can ask the questions later. Okay. I believe that the economic dispatch is part of your syllabus. Okay, for this term of economic dispatch, let me use an analogy that we usually imagine to explain about the economic dispatch. Okay, imagine you guys are at your hometown, going to travel to the city. And then first off, you guys have options on the transportation types. Let's say the red car is typically as a Ferrari, and the black one is a Myvi. So which one incur more costs, or which one consumes more fuel? And if you choose a certain type of vehicle, is it reliable enough to send you to the final destination? Or does it gonna break down in the middle of the road? Or is it gonna protect you from the extreme weather? And then along the way, as you guys will encounter a lot of difficulties on the road, there are roads that have plenty of traffic lights, or maybe dirty roads, or maybe roadblocks. This apply the same to the generation dispatch. So the goal to go to the city could be implied of the goal that we want to serve the grid system. We want to let the process to be at the lowest cost, but at the same time, it is reliable enough. And along the way, we will face operational limits that make us have to make a few sacrifices, maybe on the cost, in order to achieve our goal. So what's the definition of economic dispatch? The operation of generation facilities to produce energy at the lowest cost, to reliably serve the customers during a single period, recognizing any operational limits of generation and transmission facilities. Okay, all right, incorporate to the economic dispatch, there is two parts in our operational process that include this. The first one is the DAH scheduling, as you guys can see at the top right screen, which is planning for tomorrow's dispatch by single buyer. And then the real-time operation is dispatching the power system today by the grid system operator. So we move on to the next slide. All right, scheduling of generation resources require optimization tool and also involve transmission system security assessment to ensure grid system security. So basically, this is our process for the DAH scheduling, divided into 4 phases or 4 steps. The first one is for the input collection. We will collect all the inputs every day before 10 a.m., the time that we will start to run the simulation for the DAH report. So for the input, the first one that is the most crucial one, as mentioned by Cik Husna just now, is the system demand from the load forecast team who are also in single buyer. And then we will have the generators data, which is the availability of the each power plants. We have to know if there are any outages for their maintenance work, or if they are not available for electricity dispatch. And then we will have the fuel data, which we will gonna monitor by week or months regarding the availability of the fuels like gas, coal, or water. And we'll also acquire the system network constraint from GSO, as well as the interconnection availability. We will explain in more details of the input collection later in the slides. And then we'll start to the second phase, the simulation. So as we gather all of the input and enough at 10 a.m., we will start the optimization process. We put the input into optimization software, which we call PlaxOS, which uses the optimization solver, for which for us, we are using the Express solver that is also available in the market. And then at 12 p.m., we will submit our first result to GSO for the first assessment. Please take note that these 3 steps are iteration processes, in which if the assessment found that the requirement has not been met, we will start at phase 1 again. So, and if the assessment is okay, we will proceed to step 4. We'll display the output and results, which I will talk in details more later. Okay, go to the next slide. I will pass this presentation to Cik Zuhairi to explain more about the input collection.
Okay, thank you, Cik Izzuddin. So as you may notice, these are more details explanation with regard to the input collection. There are 7 items that have to be considered prior to the simulation process. All right, let's start with the number 1, system demand. This is where basically the profile is dependent upon the weather, human behavior, or how they consume the electricity on a daily basis. And RE, renewable energy, is also another factor that could influence the demand profile, especially RE connected at the distribution level. The second item is the generator availability. All generators are responsible to declare their availability for the next day. So from here, we can have the information on planned outage or forced outage, and also temporary reduction of their capacity. The third item is the generator contractual parameters. So when we talk about contract, we always refer to the agreement or what we call it PPA, or Power Purchase Agreement. In this agreement, it contains the technical and commercial data for the generator. For example, the minimum capacity, the maximum capacity, the RAM rates, and etc. And then for the commercial data, we have like the heat rates, variable operating rates, startup costs, and etc. The fourth item is the fuel availability. This is very important to ensure that we have the adequate fuel for the generators. For example, we have gas availability. This information is provided by the gas supplier. At the moment, our gas supplier is Petronas, so we have the continuous communication with them. And then for hydro plant, we do monitor the lake level status so that we know how much water can be discharged from this type of power plant. And coal stock is also being monitored closely, which is obviously meant for coal-fired plants. Moving on to the next item, fuel prices. This is an important element in determining the generation cost. So all this information must be obtained prior to the simulation process. We have a dedicated unit that is in charge of fuel price. So we have always in a good communication with them to ensure we reflect the latest prices for our simulation. And then system constraint is another crucial information required in this process. For example, a general information on the inter-area power transfer limit. This limit is basically provided by the grid system operator to us in advance. For instance, the allowable power transfer from north to central is about, this is just an example, 2000 megawatt. So we have to consider the transfer limit from north to south. Then we have to plan it accordingly. Another example is a mass run generator. For hydro plant, we have to ensure that there is always a minimum discharge from the plant to the downstream, because as we know, there are a lot of downstream activities happening. For instance, ada apa ni fishery or ikan sangkar punya activity, irrigation for padi, water treatment plant, and etc. So every day we have to incorporate this requirement into our day-to-day plan. And then the last item is the interconnection. Two things that we require from this item, which are the availability and the price. So basically, this information is provided by our neighboring country, Thailand and Laos, on a daily basis. So they will declare their availability together with the price that they would like to sell to Malaysia lah, sell to Peninsular Malaysia. So okay, that is basically the detailed explanation on the input collection. Let's see what is the next slide. All right. Okay, this is the, as you can see, this is the objective function lah of the whole process lah, the optimization software, which is to find an optimal solution. In bracket tu, minimum generation cost, whilst observing to the certain relevant constraints. So the formula is there, the objective function, which is to minimize the cost. And the elements of generation cost too, we have generator fuel and VOR. VOR stands for variable operating rate, and also generator start cost. And at the bottom too, we have some other inputs lah. If we have that information, it will be considered, such as contract purchase cost, transmission wheeling, and ancillary services. If we have that information, then we can incorporate that into the optimization process. And also, in minimizing the cost too, we have to observe the constraints available in the system. For example, the energy balance constraint, operation reserve constraints, and so on lah. Kita ada grid related constraint, generation related constraint, fuel related constraint, and maybe in the future we have these emission constraints. So all these constraints must be considered in doing the optimization process. All right, moving on. Okay, this is I want to show you an example on how we calculate the generation cost. What are the elements? What are the elements that consist in this generation cost? So basically, there are two main components in determining the generation cost, which are the fuel cost and the variable operating rate cost. So the formula is pretty much it's quite simple. Just add these two items, fuel cost plus the VOR cost, and then we look into each of the costs. So the first one is fuel cost. It is the fuel price provided by the relevant parties in single buyer, and then this also we need to have the PPA heat rates lah. So the formula to derive the fuel cost is at the bottom there. Fuel price multiplied by the heat rates and multiplied by the net electrical output, or you can say the loading of the machine for certain period of time. All right, you can see the example. Let's say we have fuel price. The cost is about 27 ringgit, 20 cent per gigajoule. The heat rate, assume we have 7.5 gigajoule per kilowatt hour. So the generating capacity of 1000 kilowatt for 24 hours. So if we run this machine for 24 hours, so the net electrical output is just simply multiply the 1000 kilowatt hour with the running hours lah. So in this example, the total NEO stands for net electrical output. So the total NEO is 24 kilowatt hour. So once we have this information ready, we just can plug in into the formula lah, fuel cost. So fuel price multiplied by the heat rates and multiplied by the net electrical output. So we can get the final fuel cost is around 4,896 ringgit lah. And then another element is variable operating rate cost. So basically this cost is meant for maintenance of the plant's wear and tear, and also water and auxiliaries requirement for this plant to operate lah. So this time around, the formula is much simpler. Just multiply the VOR with the net electrical output. So we can see the example at the right side, the variable operating rate. Let's say we have 4.5 cents per kilowatt hour, and then the NEO is similar to the top example just now. Is about 24,000 kilowatt hour. And then once we have the information ready, just plug in into the formula. It's very simple. Just multiply the VOR with the net electrical output. So now the VOR cost is around 1,000 ringgit lah. Thus, for the generation cost, we just add these two costs together. So the result is around 4,897 ringgit. That is the generation cost lah. So as you can see, the main or the dominant cost in this formula is fuel lah. The VOR2 is very minimal lah as compared to the fuel cost. All right, let me go to the next one. Next slide. Okay, just now I mentioned about heat rate. So maybe you all wonder what is heat rate. So by definition, it is an amount of fuel required to generate 1 unit of electricity. So this is an example of the heat rate curve. So when we plot the heat rate curve, actually this heat rate curve is provided in the agreement lah. We can just take out the heat rate and plot it. So this is how it looks like lah. So it is going down from the minimum to maximum. And then another form of heat rate is heat input. It is typically expressed in a quadratic function of the thermal generator power output. So this is basically the inverse of the heat rate curve just now. So now the trending is different, is increasing as compared to the heat rate curve. The bottom is the heat input curve. So these two elements will be used in the next slide. So can we go to the next slide? All right, this is what happened in the optimization engine lah. So basically the heat rates conversion process to be used for dispatch decision. So number one, we just derive the heat input function from the average heat rate. So you can see at the left side is the example of heat rates according to the type of power plant. So we have combined cycle gas turbine CCGT represented by the blue line, and then coal orange, and followed by open cycle lah, the gray colored line. So this is the example of heat rate curve lah, according to the type. So what do we do with this heat rate? So it will be converted into the heat input function, and then from the heat input function, we just we find the slope of the curve according to the suitable number of tranches. Basically, the tranches is to simplify the slope lah. Or we call it apa tu, piecewise linear ni lah, piecewise method. So kita boleh slice down lah the heat rate curve tu, the heat input curve tu, to get the best estimation of the slope. So from the slope too, we can determine the incremental marginal heat rates. So these incremental marginal heat rates will be used for the dispatch decision for all the machine lah. So the process are automatically conducted in the optimization software due to the following reason. The power demand variation is in very single period, because as you know that our demand profile is not flat throughout the day. It varies, and then many units in the system with different characteristics. For example, in our system we have more than 100 units available. So each of these units has their own heat rates. So it will be very difficult to do this manually. That is why we need a software to do this job. And then also we need to consider plant limitations, fuel constraints, network constraints, and so on. And also we also bounded by the timeline spelled out in the guideline. So we have to submit our plan to the grid system operator by 5 o'clock lah. So if we do this manually, then it will take forever to complete the process. So this is basically what is happening inside the engine lah. So this is just one sample lah, but all this optimization will consider more than 100 units. So there is a lot of combination involved, a lot of iteration, combination to find an optimal solution. All right, and we go to the next one. So this is just to show you the assessment part. So what do we do in the assessment? So just now we have 4 phases of processes. This is the assessment. So as you can see, we have a Plex source. This is our software, and then this Plex source will produce the generation planning, the loading for each machine, and then this output will be passed to the grid system operator to do the power flow analysis. So they will look into the details lah. The software that they are using is PSSE. So what are the parameters that they are monitor? The line loading limitation, inter-area power transfer limit, and also voltage support. So this is a separate process altogether. So we have to communicate frequently with the GSO to ensure that there is no violation lah in the plan. All right, another thing that we have to do is a sanity check lah, basically to find any abnormalities in the result lah. So from the result too, we could see we can see the pattern, we can see if there any unserved energy, we can see the logic of the output in terms of generation mix, and also the gas requirement. So basically, there are several parameters that we observe in doing the assessment. And then any transmission, network violation, or any simulation related error will require us to repeat the simulation process lah. So again, this is an iterative process lah. It has to go on and on and on sampai lah all parties satisfied lah. All right, moving on. Okay, so we have another 7 minutes. This is a sample of output from our optimization process. So, for publication, we do publish system marginal price and also generation mix. This is for the market player lah, to do their analysis, their business call lah, based on this information available in the website. And then we have a generation dispatch plan. This information is being passed to the JSO, to the dispatcher, to perform their dispatch in the real time. And then also we have a gas requirement. This information will be passed to the to Petronas, so that they can strategize their production accordingly. The publication is mandatory according to the guideline for single buyer market and other guidelines. So if you have time, you can go to our website to see this information. It is ready in the website. So can we move on to the next slide? Okay. Okay, generator are stacked from the cheapest to the most expensive generation cost to meet the demand whilst adhering to certain relevant constraints. So the chart with yang area tu, the blue black, the light blue, the green, actually that represent the demand lah, the demand profile, for the day. So we have a list of generators stacked they have their own, each of these generators have their own cost. So the way we do the stacking, or the way we meet the demand, is just simply dispatch the most cheapest dulu lah, and then kita stack sampai yang last kali tu to meet the system demand lah. So as you can see, the blue colored, the dark blue tu represents the base load lah. The base load plant normally consists of the thermal plant, and then followed by the combined cycle gas turbine, and then to meet the spike or the peak demand, we have a peaking plant lah. We have hydro and open cycle gas turbine to do the peaking, to do the peak shaving. We call it peak shaving. Again, at the bottom we have the formula on how we derive the generation cost per unit. Just the three elements there. Just remember, we have heat rates, gigajoule per kilowatt hour, multiplied by the fuel price, and then plus the VOR lah, variable operating rate. So okay, that's about it for this particular slide. Can we go to the next slide? All right. Do we have time for a quiz? It's well, we have prepared. It's a very simple quiz for you to answer. Just quickly go through the quiz.
Okay. So this is the last part of our presentation. We have a quiz for you. We won't take more than 5 minutes. So take out your mobile phone, or you can also use your laptop. Go to joinmyquiz.com, and there you will see you have to enter the code. And the code for this quiz is 261373. Okay, we have 2 participants, but I see we have about 125 participants altogether in this WebEx. So I hope maybe we can have around 60. Shafiq, Firdaus, Aiman. Okay. Bakal DNB. Okay. Can put any names you want, any fun and appropriate name. So far we have 31 participants. This is just a 5 questions quiz, so it won't take long and you will have 30 seconds to answer each of the questions. Perhaps another 7, make it 50. Four participants. Five. 6. We have Corona here. Okay. Okay, I'll close once we reach 50 participants. Okay, 51. All right. Okay, I'll start the quiz. Okay, keep you ready. You have 30 seconds to answer each question, okay? Let's start. Okay, the first question. Which one below is not related with least cost generation scheduling? 1, sustainable. 2, constraints. 3, reliable. 4, economical. Pick. You have 12 seconds. 10. 4, 3, 2, 1. Okay, you need to be fast to answer this. All right, so far who is leading? We have Amar Bahar. Oh no, we have Iskandar just now. Right, the right answer is sustainable because it is not related with this cost generation scheduling. The rest should be related to this cost generation scheduling. Okay. Next question. One of the processes involved in least cost generation scheduling is processor, dispatcher, economic situation, conduct simulation. So what is the process that actually involved in least cost generation scheduling? Another 30%, 6, 5. Let's see who's leading. Sharifah is leading, congratulations. And the right answer is conduct simulation. All right, next question. What is the main input required in least cost generation scheduling? Simulation, availability, i.e. fuel generation, assessment, or analysis and reporting? All right. Is Sharifah still leading, or do we have another leader, Azhar? Okay. The right answer is availability. Congratulations, everyone. Most of you got it right. Okay. What is the optimization tool used to conduct least cost generation scheduling? MATLAB, Simulink, Blacksource, AutoCAD. This should be the easy one. Who's still leading is Azhari. Right. Right. Most of you get it right. Congratulations. Blacksource is the correct answer. Okay, this should be the last question, I think. One of the outputs produced for least cost generation scheduling is cryptocurrency price, mixed integer programming, system marginal price, generation unplanned outage. One of the outputs that we produce. We have 5 seconds. Time's up. So the correct answer, okay, still leading is Azhari, still leading the quiz. All right, correct answer is system marginal price. Yep. Okay. Thank you everyone for participating in our quiz. I'm sure most of you are tired already with the 2 hours long of presentation. Feel free to check out our Single Bio website. We also have SB newsletter, What's Up, in our website, where we update our latest news and our latest project. Thank you very much. I hope these 2 hours can be beneficial for most of you. All right, Israeli.
All right. I also have nothing much to say. Just thank you for your participation and thank you for listening. Let's say if you have more questions, you can always talk to your prof, and then she will pass the question to me, and I will try my best to answer them. All right. With that, Assalamualaikum warahmatullahi wabarakatuh.
Salam. Terima kasih saya ucapkan kepada Cik Zuhairi dan Cik Husnan di atas pengkongsian ini. Alhamdulillah saya dan pelajar-pelajar yang lain telah mendapat ilmu baru seperti jenis-jenis stesen jalan kuasa di Malaysia, demand electricity dan juga least cost generation scheduling. Oleh itu, semoga apa yang kita dapat hari ini tidaklah hanya sekadar masuk telinga kanan, keluar telinga kiri, tapi juga dapat dikaitkan dengan apa yang dipelajari dalam kelas. Baiklah, nampaknya masa amat menceburi kita. Saya berharap kita dapat sama-sama mengambil perkara yang positif daripada perkongsian pada petang ini dan menjadikannya sebagai inspirasi untuk terus mengorak langkah menuju kejayaan. Dengan itulah program kita iaitu Industrial Talk EPO522 Least Cost Generation Scheduling pada hari ini. Oleh itu saya Muhammad Hakim Imandia selaku moderator pada petang ini ingin mengucapkan ribuan terima kasih kepada panel jemputan dan juga peserta yang terdiri daripada mahasiswa dan mahasiswi UiTM yang sudi hadir ke program Industrial Talk pada hari ini. Kita akhiri majlis kita pada hari ini dengan tasbih kifarah dan surat al-as. Sekian, wabillahi
Terima kasih.
taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih semua kepada speaker. Okay.
Okay, terima kasih.
Sama.